This is lesson 3.4, inverse of a square matrix. You should have the form out with you and be taking notes on this. So, PowerPoint. Remember, the identity of a matrix is a square matrix. Let's move this out of the way. There. With diagonals of 1s and 0s everywhere else. Special property of an identity matrix is if you take A and multiply it by the identity, you will get the same matrix A. Also, if you multiply the identity times the matrix, then you will get the matrix again. This defies the commutative property. Well, this is the commutative property, but when you multiply two matrices together that are not identities, they are not commutative, and we learned that earlier. So here, if we say A times the identity, and identity times A, it shows us that we get the same matrix. So let's put the inverse in first. Second, let's turn it on. Second matrix, edit. We need a 5 by 6. A 2 by 2. And this is 5, 6, 4, 2. I think there is an identity. Let's look and see. If we go into math, I guess not. Let's put in the identity matrix then. So we'll need to go down to matrix B. It is as well a 2 by 2. And 1, 0, 0, 1. So that's the identity matrix. So if we say matrix A times matrix B, we get what we started with. If we say matrix B times matrix A, again we get what we started with. So what it's saying is that the identity, when you multiply by the identity, it is commutative. Square matrices A and B are called inverses if you multiply the two of them and you get the identity. Whether you multiply A times B or B times A, you have to get the identity if they are inverses. So we must show both A times B and B times A, and we get the identity. So there's matrix A, and if we put it on one side and the identity on the other, our goal is to get the flip-flop. So we're going to take this, and I'm going to show you by hand, and then you can watch it by the equations. So we need to get this to a 1, this to a 1, this to a 0, and this to a 0. So first off, we're going to multiply by 1/3. That's not what we get. 1/3 times 3 is 1. 1/3 times 7 is 7/3. 1/3 times 1 is 1/3. And 1/3 times 0 is 0. And then we will not touch the bottom row. So what we're doing is working here to get the identity. So we need to make this a 0. So we're going to multiply by the opposite and add it and leave. So the top will stay the same. And the bottom's going to change. So negative 2 times 1 is negative 2, plus 2 is 0. Negative 2 times 7 over 3 is negative 14 over 3, plus 5 is 1/3. Negative 2 times 1/3 is negative 2/3, plus 0 is negative 2/3. And negative 2 times 0 is 0, plus 1 is 1. Alright, so now we need to get this to 1. So we're going to multiply by the reciprocal. I'm going to come up here. So the top row is going to stay the same. Three over 1 times 0 is 0. 3 over 1 times 1/3 is 1. 3 over 1 times negative 2/3 is negative 2. 3 over 1 times 3 is 3. So we've almost got the identity. We just need this to go to 0. So if I multiply by the opposite and add it back to it, so the bottom's not going to change. So negative 7/3 times 0 is 0, plus 1 is 1. Negative 7/3 times 1 plus 7/3 is 0. 14 over 3 plus 1 over 3 is 15 over 3, which is 5. And negative 7 over 3 times 3 is negative 7 plus 0. So since we have the identity, this would be considered the inverse matrix of this. So now let's watch it with the equations. So they multiplied by 1/3, just like we did. They multiplied by negative 2 and added it back. So, same thing that we did. Okay, so when you have the identity on the left side, you're finished. The inverse is on the right side. So, this is A inverse. Notice how it is written. How it's got an A to the negative 1. Alright, so now find it on the calculator. Put matrix A in the calculator. Return to the home screen. Hit second matrix to get the name of your matrix and hit enter. Hit the X to the negative 1 key. Hit enter. Alright, so let me pull up my calculator. And turn it on. So second matrix A. I don't know what. Let me see what the 3725. Alright, so let me get the calculator back up here. So matrix A. Oh. We want to edit matrix A. It is a 2 by 2, 3, 7, 2, 5. And let's see what it says. Alright, so put matrix A in the calculator, we did. Return to the home screen, we did. Hit second matrix, pull up the name, we did. Hit X to the -1 key, that's right there. And then hit enter. 5, -7, -2, 3. So yes, that's what we ended up with. So uses for inverses of matrices to solve a system. Well, before we do that, I thought we have to prove it the other way. Uses for inverses of matrices to solve a system. If we have the system, we can write a matrix like this. Use this method if your calculator does not have the RREF function. So find the inverse of A, and so we just learned how to do that by using row operations until you get the inverse on one side. But if you look here, we've got 2 zeros here. Once you've got a 0, you can't get it back to a 1. So it says, what now? It says, once the bottom row becomes all zeros, you cannot get a 1 back. This means that the matrix A does not have an inverse. It is a singular matrix. So it says, try this on your calculator. Let's go to the worksheet and see if that got everything on the worksheet. Show that A and B are inverse matrices. Okay, if there's something that I didn't do from the worksheet, just let me know in class and I will go over anything that you need help on or anything that I missed.